Our next presenter is Lauren Switala, The Road to the Heart for Gene Therapy.
When we think about heart disease, we tend to think of environmentally induced disease that might be the result of diet or exercise. There's another category of heart disease, or cardiomyopathies, that are genetic in nature. For patients with these disorders, their body's instruction manual, their DNA, has a broken piece in it, like the heart on the right. There's a malfunction in this DNA that might not let a patient make a certain protein, or maybe they make a protein incorrectly, depending on the mutation. As you can imagine is the case for someone whose heart does not work, these diseases tend to be severe and can drastically shorten a person's life, with many of these disorders leading to death in children. But in the past 50 years or so, the technology has been developed with the potential to cure these diseases, gene therapy. Basically, this is a vehicle, like the truck on the left, that carries a healthy gene to correct for the broken one. Gene therapy has already been successfully used to treat diseases in other organs, but not yet the heart. The heart is particularly difficult for medicine to get to because it's heavily protected, which makes sense because it's so important to keep you alive. But this protection results in some obstacles on a medicine's road towards it when it's going through the body. When a person receives gene therapy, that therapy has to navigate the road, the circulatory system, and make sure not to turn towards off-target organs like the lungs or the liver, which is a common problem in drug delivery. If too much medicine goes to the wrong place, there's not enough left to be effective in the heart. So the therapy has to see the correct traffic signal, chemical messengers that we call chemokines, to get to its destination. Next, however, it still has to evade antibodies, which I'm representing with a police officer, that neutralize the therapy before it can get where it's going. Now, we all have these antibody officers, and usually they keep us safe and healthy. But in this case, while they think they're stopping a criminal from getting to the heart, they're actually stopping the good guy truck that's on its way to save the heart. So the goal of my project is to turn the traffic signal green, to go straight towards the heart, and to prevent interference from these antibody officers, basically by letting the therapy pass while they're off duty. Now, the way we do this is simple. We deliver a primer particle to the patient first, going into direct traffic by sending out heart-friendly chemokines through the body. And then the subsequent administration of the gene therapy can successfully make its way to the heart, now that it knows where to go. We're essentially ushering the truck to its destination. By enabling the delivery of gene therapy to the heart, my project is opening the door to effectively curing genetic cardiomyopathies. We're simply overcoming the obstacles on the road for this life-saving medicine. Thank you.